In October of 2017, a moment of scientific history quietly unfolded in a way that no one anticipated, and yet it would spark one of the most fascinating discussions about our place in the universe. It began like so many other nights at the observatories, with astronomers scanning the heavens, searching for near-Earth objects, asteroids, or comets whose orbits might bring them close to our planet. This routine process, repeated thousands of times, is part of humanity's vigilant watchfulness, and yet on October 19th of that year, an object appeared on the Pan-STARRS 1 telescope in Hawaii that would forever alter our understanding of what is possible in the cosmos. The object was small, faint, and initially seemed unremarkable, but the subtlety of its movement across the night sky contained within it a revelation. Its speed, its trajectory, the very path it carved through the gravitational well of our sun, all of these whispered something extraordinary. This object did not belong to our solar system. It was a visitor, a traveler from another star, the first of its kind that humanity had ever seen. For centuries, human beings have looked up at the stars and wondered whether those distant suns bore their own worlds, whether comets and asteroids might wander between systems, carrying with them the stories of creation written in stone and ice. But such ideas remained theoretical, confined to speculation, until that fateful night when Pan-STARRS captured the faint glimmer of an object hurtling through space at impossible speeds. At first, it was catalogued like any other near-Earth object. The early designations did not yet capture its uniqueness, but as more observations came in over the following days, it became clear that this was not an ordinary discovery. Its orbit was hyperbolic, meaning it was not bound by the gravity of our sun. It was simply passing through, making a single fleeting visit before slipping away into interstellar space forever. This was the first confirmed interstellar object in recorded history. Humanity had, for the first time, come face to face with material from beyond our solar system. The discovery was thrilling not only for its rarity but also for its symbolism. For generations, astronomers had theorized that interstellar debris must exist. Planetary systems form in violent processes, with countless fragments of rock and ice flung into the void during their birth. Some of these wanderers, cast out into the galactic sea, would travel for millions or billions of years, eventually brushing past other stars. And yet, despite the vast number of such objects predicted to exist, none had ever been detected, until Oumuamua. Its sudden appearance confirmed the theory, not through equations or conjecture, but through direct, undeniable observation. For the first time, the abstract idea of interstellar travelers was made real. Imagine the awe felt by those astronomers when they realized what they were looking at, an object born of a distant star system, shaped by conditions unlike our own, had drifted across the abyss of space and entered our neighborhood. It had perhaps traveled for hundreds of millions of years, enduring collisions with cosmic dust, reshaped by the radiation of alien suns, tumbling silently through the galaxy until chance and cosmic alignment brought it within reach of human eyes. To us it appeared suddenly and fleetingly, like a messenger from the unknown, reminding us that our solar system is not isolated. We are part of a galaxy alive with movement, where countless objects wander unseen, waiting for the chance encounter that will bring them into our awareness. The very act of discovery was itself a triumph of human vigilance. Pan-STARRS was built to safeguard Earth by identifying potentially hazardous near-Earth objects. It was designed to scan vast swaths of the sky, tracking anything that moved. And yet, its greatest discovery was not one that threatened Earth, but one that expanded the horizon of our imagination. Oumuamua was small, only a few hundred meters in length, but its importance was vast. Without such dedicated sky surveys, it would have passed unnoticed, slipping silently through the solar system without anyone on Earth being aware. Instead, because of our ceaseless watchfulness, we caught a glimpse of history. The announcement of Oumuamua's discovery spread quickly across the scientific community and into the public imagination. Here was something tangible, something that confirmed humanity's long-standing belief that the universe is full of wanderers. And the name chosen for it was deeply symbolic. Astronomers turned to the Hawaiian language, naming it Oumuamua, which means a scout, a messenger from afar arriving first. This name captured the essence of the discovery, not just an object, but a harbinger, a sign that the universe beyond is not silent. It was the first, but it may not be the last. The name was a reminder that this was a moment of contact, however brief, between humanity and the greater galaxy. The realization that Oumuamua was interstellar raised countless questions. What star system had it come from? How old was it? What collisions or ejections had flung it free of its parent star? What tales of creation did it carry in its silent, tumbling form? Each question expanded our sense of mystery. Humanity, for the first time, was confronted not with theoretical interstellar matter, but with a piece of it moving before our very eyes. And yet, in its speed and trajectory, it also carried with it the frustration of distance. By the time we recognized its true nature, it was already speeding away from us, slipping further beyond our reach with every passing day. It was a fleeting encounter, like catching sight of a stranger passing quickly through a crowded street, never to be seen again. And this fleeting nature gave the discovery an almost poetic weight. Oumuamua was not an object we could chase, not one we could probe with a spacecraft, not one we could capture. It came suddenly and left just as suddenly, and we were left only with the memory of its presence and the limited data our telescopes could capture in that short window. Its discovery was a reminder of the vastness of the cosmos, of how small we are and how rare it is to be in the right place at the right time. It was also a reminder of the importance of vigilance, for the universe is full of such moments, and the more we look, the more we will see. The fact that Oumuamua was the first does not mean it will be the last. In truth, its discovery almost guarantees that many more interstellar objects will pass through our solar system. Pan-STARRS caught this one, but the universe is full of countless more. The discovery is not just a singular event, but the beginning of a new era in astronomy, one where we will begin to watch for and study the visitors from beyond, each carrying within it the secrets of distant suns and worlds we may never otherwise know. Humanity, in discovering Oumuamua, opened the door to an entirely new field of exploration, the study of interstellar messengers. For the scientists who first realized what they were seeing, the discovery must have carried a profound emotional weight. Here was proof that we are not alone in the sense that our solar system is not a closed system. The boundaries of our cosmic neighborhood are porous. Material moves between stars, and in so doing, it connects us to the greater galaxy. Each interstellar visitor is a bridge, a connection between our world and worlds unseen. Oumuamua was the first such bridge we recognized, the first time we could point to something and say, "This does not come from here, it comes from the beyond." That realization, simple yet profound, is one of the most important moments in the history of astronomy, and beyond the science, there is the symbolism. Humanity has always longed for contact with the unknown, for signs that the universe beyond holds meaning for us. Oumuamua was not a spacecraft, not a message intentionally sent, but it was still a message nonetheless. It was the universe saying, "Look, you are not isolated. You are part of something larger. The galaxy is alive with travelers, and this one, by chance, has crossed your path." In that sense, the discovery was more than scientific. It was spiritual, philosophical, a reminder of our connection to the vastness of creation. The story of Oumuamua's discovery is, at its core, a story of human curiosity meeting cosmic mystery. It is a story about how routine vigilance can lead to extraordinary revelation, how a faint dot of light on a telescope image can unfold into a narrative that reshapes our understanding of the universe. It is a story of fleeting contact, of a messenger that came and went, leaving behind only questions and inspiration. And it is a story of beginnings, because in seeing this one visitor, we know now to expect others. The first scout has arrived and more will follow. In years to come, humanity may develop the technology to intercept such objects, to send probes to study them up close, to capture samples of alien material drifting through the galaxy. We may learn about the chemistry of distant star systems, about the building blocks of planets and life that exist far beyond our own. Oumuamua, in its discovery, opened that door. It reminded us that such opportunities are not just possible but inevitable. And it challenged us to be ready to build the tools, the missions, the vision that will allow us to grasp the next messenger that crosses our path. The discovery of Oumuamua was not just an astronomical event, it was a human event, a reminder of who we are and what we seek. We are explorers, dreamers, watchers of the stars. We search not only for threats, but for meaning, for connection, for signs that the universe beyond is alive. And when we found Oumuamua, we found all of these at once, a threat to nothing, but a gift of wonder, a connection to distant worlds, a sign that we are part of a galaxy teeming with movement. It was the first scout, and in its fleeting passage, it reminded us that the universe still has secrets to share, if only we are willing to look. When humanity first encountered the strange interstellar visitor in 2017, one of the most profound and poetic moments came not from the mathematics of its orbit, nor from the analysis of its unusual acceleration, but from the simple human act of giving it a name. For centuries, we have named the objects in our skies. The constellations bear the myths of ancient Greece, Babylon, and countless other civilizations, each culture leaving its mark upon the heavens. Our planets carry the names of Roman gods. Our comets and asteroids are often named for the scientists who discovered them. Naming is not just a label, it is an act of claiming connection, of weaving an unknown object into the tapestry of human culture. And so, when astronomers realized that this new object was the first confirmed interstellar visitor, the name chosen for it would matter deeply. It could not be arbitrary. It had to carry the weight of history, the awe of discovery, and the symbolism of contact with something from beyond our world. They chose a word from the Hawaiian language, Oumuamua. At first glance, it may seem curious that this name should come from Hawaii. But it makes perfect sense. The telescope that first detected the object, Pan-STARRS 1, stands atop Helikala on the island of Maui. Hawaii has become one of the world's great windows to the universe, with its clear skies and high mountaintops, hosting some of the most advanced observatories in existence. From this island in the middle of the Pacific, humanity's vision stretches far across the cosmos. And so, it was fitting that the name should honor the culture of the land where the discovery was made. The word Oumuamua is rich with meaning. It translates loosely as a scout, or a messenger from afar arriving first. This choice was not merely poetic flourish, it was a recognition of the object's role in our history. Oumuamua was not just another rock drifting through space, it was the first, the herald, the one that came before all others. Like a scout moving ahead of an unseen caravan, it was a sign that there are more to come, that the galaxy is alive with travelers, and that this was merely our first encounter. The name carried within it the weight of anticipation, the suggestion that this was a beginning, not an isolated incident. There is something deeply human about the act of interpreting natural events as messages. For millennia, we have looked at comets and supernova as omens, as signs from the heavens. In earlier ages, such events might inspire fear, seen as warnings from the gods. In our time, we may be more scientific in our interpretation, yet the instinct remains. When something unusual appears in the sky, we ask ourselves, what does it mean? What is it telling us about our place in the universe? By calling this visitor Oumuamua, we acknowledge that instinct. We admitted that we felt in its arrival not just randomness, but significance. A messenger had come, and though it spoke no words, its very presence was a communication from the greater cosmos. The name also captured the fleeting nature of the event. A scout does not linger, it passes quickly, surveying the land before moving on. So too with Oumuamua. By the time we realized what it was already racing away, leaving us only a brief window of observation. It came swiftly, stayed briefly, and then was gone. The name encapsulated that fleeting quality, the sense of a visitor passing by with haste, as if it had more important places to be, other stars to visit, other systems to scout. Its sudden arrival and swift departure made the metaphor of the scout all the more fitting. To understand the depth of this naming, we must also appreciate the Hawaiian cultural perspective. Hawaii is a land with a rich tradition of navigation and exploration. The Polynesians who first settled the islands were among the greatest seafarers in history, crossing vast stretches of ocean guided only by the stars, the currents, and their profound knowledge of nature. In that tradition, the concept of a scout carries special meaning. A scout is the one who ventures ahead, who tests the waters, who finds the path for others to follow. The choice of a Hawaiian name tied the discovery to that heritage of exploration, reminding us that humanity, too, is on a voyage across the great ocean of space. Just as the Polynesians once looked to the stars to guide them across the seas, so now do we look to the stars to guide us across the cosmos. Oumuamua in this light was not just a rock, but a canoe arriving from another island across the galactic ocean, reminding us that we are not alone on this endless sea. The act of naming also transforms how we think about an object. Before it was named, it was cataloged with a sterile designation, 1I/2017 U1. 1I stood for the first interstellar object ever detected. It was accurate, clinical, and utterly devoid of soul, but when it became Oumuamua, it acquired a story, a personality, an identity. It became more than data points and orbital parameters. It became a messenger, a scout, a visitor. That transformation in language reflects something profound about human nature. We cannot connect deeply to numbers alone, but through story, symbol, and name, we find meaning. By naming it, we drew it into our shared human narrative, making it not just a scientific discovery, but a chapter in the story of humanity's awakening to the galaxy around us. Consider how this name resonated with the public. When news of Oumuamua spread beyond the scientific community, it captured imaginations not because of its catalog number, but because of its name and what that name suggested. A messenger from afar arriving first. What more evocative phrase could there be? It stirred speculation. If this was the first, how many more are out there? If it was a messenger, what was it bringing? Was it simply a fragment of rock? Or was there something more mysterious behind its peculiar behavior? Some even speculated that it could be artificial, a probe or a sail sent by another civilization. Whether one believed in those theories or not, the very fact that the name could spark such questions showed its power. Oumuamua was not just a piece of stone. It was an idea, a symbol, a spark for human imagination. This, too, is the power of language. The Hawaiian word reminded us that science and culture are not separate, but intertwined. A discovery is not complete until it enters human culture, until it resonates with our stories, our heritage, our imagination. In choosing Oumuamua, astronomers acknowledged that this was not just a scientific finding, but a moment of human significance. They honored the land where the discovery was made, and they gave all of us a metaphor by which to understand it. The scout, the messenger, the herald. These are ideas that resonate across cultures, across time. They give us a way to talk about this strange visitor, not only in terms of equations and data, but in terms of meaning. What is particularly striking about the name is its forward-looking nature. By calling it a scout, we are invited to anticipate what comes after. A scout, by definition, is not alone. It comes ahead of others. The implication is clear. There will be more. This is not an isolated event, but the beginning of a pattern. Oumuamua may have been the first interstellar object we detected, but it will not be the last. Already in 2019, another was found, Comet Borisov, confirming that interstellar visitors are not rare flukes but part of the living exchange between star systems. In that sense, Oumuamua lived up to its name. It was the scout, and others followed. Its name was not just descriptive but prophetic. This notion that names carry prophecy is not new. In many traditions, to name something is to shape its destiny. When we named Oumuamua, we were not only describing what it was, but declaring what it meant for the future. It was a scout, and so we began to look for more, and indeed more came. The name shaped our expectations, and those expectations shaped our science. Telescopes are now being built, and missions proposed to study future interstellar visitors. The name was not just a label, it was a call to action, urging us to prepare for what comes next. But there is yet another layer to the symbolism. A messenger does not arrive without purpose. Even if it speaks no words, even if it carries no intentional message, its very arrival communicates something. Oumuamua told us that the galaxy is not silent. It told us that the boundaries of our solar system are not walls, but open doors through which objects can pass. It told us that we are connected to the wider galaxy in tangible ways, And in a more philosophical sense, it told us that we are being watched, not by civilizations perhaps, but by the universe itself, which sends us reminders that we are part of a greater whole. To call it a messenger was to acknowledge that we heard the message, even if we are still deciphering what it means. In the end, the meaning of Oumuamua lies as much in the name as in the object itself. The rock or ice that sped through our solar system is now gone, forever out of reach. Its physical nature may remain a mystery, but the name endures, and with it the story. Oumuamua has become a symbol, a word that carries within it the sense of wonder, of connection, of anticipation. It is not just the name of a celestial object, it is a metaphor for humanity's place in the galaxy. We are no longer isolated, we have seen the first scout, and we know that we live in a universe filled with travelers. The Hawaiian name given to this visitor will echo in history not because of the object itself, tiny, faint, and fleeting, but because of what it represented, a scout from afar arriving first, leaving behind a message not in words but in presence. A reminder that we are part of a larger story, one that stretches beyond the sun, beyond our world, into the vast and mysterious sea of stars. When Oumuamua was first detected, it appeared as nothing more than a faint point of light drifting across the background of stars. But as astronomers began to track it, to measure its orbit, its brightness, and its peculiar properties, they realized they were looking at something unlike anything they had ever studied before. It was one thing to call it an interstellar visitor, to marvel at the fact that it came from beyond the sun's dominion, but what deepened the mystery was how strange it was. Everything about Oumuamua defied the categories we had used for decades to classify small bodies in our solar system. It was not quite an asteroid, not quite a comet, not quite anything we could easily name. It belonged in no familiar box, and so its uniqueness forced us to confront the limits of our knowledge. From the very start, its shape puzzled astronomers. By analyzing the way it reflected sunlight, they inferred that it was highly elongated, unlike the relatively rounded asteroids and comets we typically see. Some estimates suggested it was up to 10 times as long as it was wide. Imagine a giant cigar-shaped body, hundreds of meters long, tumbling end over end as it moved through the solar system. Later studies complicated that picture, suggesting it might actually have been more like a flattened pancake, spinning irregularly with its long axis changing as it rotated. Either way, it was extreme. No known asteroid or comet had such proportions. This elongation gave it an alien quality, as though its very geometry betrayed its foreign origin. It was not like the objects born of our solar system's processes. It bore the mark of another kind of birth, another kind of environment, somewhere far away among the stars. Its surface was also unusual. Observations indicated that it was reddish in color, perhaps due to the effects of cosmic rays and interstellar dust bombarding it for millions of years. This gave it an ancient, weathered appearance, the patina of a long traveler. In this, it shared something with many of our own outer solar system bodies, which also turn red under constant radiation exposure. But while the color was not wholly unique, it reinforced the sense of age and distance, as though we were looking at an object that had been on a journey longer than human civilization itself has existed. Yet the most mysterious characteristic of Oumuamua was its motion. Objects moving through the solar system follow predictable paths governed by gravity. An asteroid or comet drawn toward the sun will accelerate as it falls inward, then decelerate as it climbs back out. The equations of celestial mechanics are precise, and astronomers are skilled at applying them, but when they tracked Oumuamua, they noticed something that did not fit. After it passed closest to the sun, it did not slow down quite as much as expected. It seemed to be accelerating slightly, as though an invisible hand were giving it a push. This small but significant anomaly demanded explanation. The natural hypothesis was outgassing. Comets, when warmed by the sun, release jets of gas and dust that can act like tiny thrusters, nudging the comet and altering its orbit. But with Oumuamua, no visible tail, no cloud, no coma could be detected. It was moving like a comet, but looking like an asteroid. This contradiction confounded scientists. Some proposed that it was outgassing very faintly, in ways too subtle to detect, perhaps releasing only hydrogen gas, or in amounts too small to create a visible signature. Others doubted this explanation, pointing out that such behavior would itself be unusual. The mystery deepened. Why would an object show comet-like acceleration without comet-like evidence? This enigma led to one of the most daring speculations of the entire affair. A few scientists, most prominently Avi Loeb of Harvard, suggested that Oumuamua might not be natural at all, but artificial. Perhaps it was a thin, reflective sail, powered by the light of the sun, drifting through space as part of some distant civilization's technology. Perhaps it was debris, or perhaps it was intentional. While most astronomers remained skeptical of such claims, preferring natural explanations, the very fact that the question could be asked shows how unusual Oumuamua was. No ordinary comet or asteroid would inspire such speculation. Its behavior pushed the boundaries of what we thought possible, and in doing so, it blurred the line between science and imagination. Beyond its acceleration and shape, its rotation was also bizarre. Oumuamua did not spin smoothly like most asteroids. Instead, it tumbled chaotically, a kind of non-principal axis rotation that suggested it had been jostled or fractured in the past. This tumbling would have made its surface alternately warm and cold as it exposed different faces to the sun. That, too, could have contributed to outgassing in odd patterns, if indeed it was releasing material at all. But more than that, the tumbling emphasized its strangeness. It was not just traveling through space, it was dancing, rolling unpredictably, almost as though it carried within it the memory of violent encounters in some distant past. Its sheer speed was another unique factor. When it entered the solar system, it was moving at about 87 kilometers per second relative to Earth. That is far faster than any typical asteroid or comet bound to the sun. Its hyperbolic trajectory made it clear that it had come from beyond, and its velocity ensured that it would never return. Unlike a long-period comet which swings back after thousands of years, Oumuamua was a one-time visitor. It came fast, left fast, and would not be seen again. That fleetingness contributed to its uniqueness, because we had only weeks to observe it before it became too faint and too distant for our telescopes. The mystery was compounded by urgency. We were trying to learn about something utterly new with almost no time. Even its size and brightness posed puzzles. Oumuamua was smaller than many asteroids we have studied, only a few hundred meters long, and yet it reflected enough light to be detected. Its surface may have been unusually shiny, or its shape may have presented more reflective area as it tumbled. Some speculated that it might even be hollow or low density, with a structure unlike anything we had previously encountered. Each measurement seemed to raise new questions rather than settle them. It was as though Oumuamua delighted in resisting our categories, refusing to be pinned down as one thing or another. Perhaps the most profound uniqueness of Oumuamua was not in its physical properties, but in how it made us feel. Every known comet, every asteroid we have catalogued comes from our own solar system. They are family, shaped by the same sun, the same gravitational dances, the same history of collisions and accretions that gave rise to our planets. Oumuamua was not family, it was a stranger. Its uniqueness was in its foreignness, in the fact that its properties bore the mark of processes we had not seen, born in an environment we did not know. It was like finding a seashell from a distant shore washed up on your own beach. You could study its shape, its color, its texture, but you knew in your heart that it came from an ocean you had never sailed. And so, every detail of Oumuamua became a symbol of its uniqueness. Its elongated form told us it was not like our asteroids. Its lack of a tail told us it was not like our comets. Its acceleration told us that something was happening we could not fully explain. Its tumbling, its reddish color, its fleeting appearance, all of these wove together into a portrait of mystery. And in that portrait, we saw both the limits of our understanding and the vast possibilities of the universe. The uniqueness of Oumuamua also taught us humility. We had believed we knew what small bodies looked like. We had believed we could categorize every visitor into neat boxes. Oumuamua showed us that the universe is more diverse, more surprising than we had imagined. It challenged our categories, forced us to think more broadly, to accept that what is common in one star system may be alien in another. It reminded us that our knowledge is provincial, shaped by our own backyard, and that the galaxy beyond may hold wonders we cannot yet conceive. It also taught us urgency. Because Oumuamua was unique and fleeting, we realized how much we lost by not being ready. If we had had a probe capable of rapid deployment, we could have intercepted it, studied it up close, perhaps even touched its surface, but we were unprepared. Its uniqueness passed us by, and we could only watch from afar. This has already inspired new ideas, missions designed to launch quickly at the next interstellar visitor. Oumuamua's uniqueness was a wake-up call. The universe offers us rare gifts, but only if we are ready to receive them. In the years since its departure, its uniqueness has not faded. Scientists continue to debate its nature, to publish papers exploring models of its shape, its origin, its acceleration. Each new idea testifies to the richness of its mystery. Unlike so many comets or asteroids catalogued and forgotten, Oumuamua lives on in discussion, precisely because it was so different. It carved a space for itself in our imagination by refusing to be ordinary. Ultimately, the uniqueness of Oumuamua lies not only in its physical oddities, but in the fact that it was the first. It was our first contact with the wider galaxy in material form. It was the first messenger, the first scout, the first reminder that the universe does not conform to our expectations. That firstness, combined with its strange characteristics, made it unforgettable. It will forever be the object that reminded us that the cosmos is larger, stranger, and more surprising than we can ever predict. And so, when we look back at the discovery of Oumuamua, we remember not just a faint point of light in a telescope image, but a cascade of questions, a flood of wonder, and a recognition of our own smallness. Its unique shape, its unique motion, its unique fleetingness, all of these combine to make it more than just a rock. It was a lesson that the universe is not neat, a lesson that mystery endures, a lesson that we are not yet finished discovering what lies beyond. Oumuamua's uniqueness will be remembered long after its physical form has drifted into the dark. For even if we never see it again, we will always carry the memory of the moment when the universe revealed to us something utterly new. And that memory, that lesson, is the true uniqueness of Oumuamua, that it changed us ever so slightly by reminding us that the cosmos is vast and we have only just begun to understand its secrets. When Oumuamua streaked through our solar system in October 2017, it did more than just pass silently through space. It lit a fire of questions, debates, and passionate arguments among scientists and thinkers across the world. For decades, astronomers had dreamed about the possibility of one day encountering an interstellar object, and when it finally happened, humanity was confronted with something far stranger than anyone had anticipated. Its behavior defied neat categories, its appearance did not match any familiar blueprint of asteroids or comets, and so from the very first moment of its discovery, the story of Oumuamua became not only one of observation, but one of interpretation, a battle of ideas about what it truly was. That debate has not ended even years later, and perhaps it never will. At first, astronomers tried to fit Oumuamua into the categories they already knew. The most obvious possibility was that it was a comet, a frozen body from another star system, one that, like our own comets, carried ice and volatile materials within it. Yet when telescopes searched for the telltale signs of a comet, something seemed wrong. There was no glowing tail, no halo of gas and dust surrounded it as it passed near the sun. Its surface looked dark, red, and dry, much more like a rocky asteroid than an icy comet, and yet its movement suggested something else. Careful tracking showed it was accelerating slightly, as though it was being pushed by some force other than gravity. The most natural explanation for this was outgassing, the invisible jets of vapor released when ice sublimates into gas. But if outgassing were occurring, why had we not seen any visible signs? The contradiction lay at the very heart of Oumuamua's mystery. Some argued that it might not be a comet at all, but a fragment of a larger rocky body, broken apart and flung out of its parent star system long ago. Perhaps a planet had been shattered, or a comet had collided with another body, and Oumuamua was just one shard among countless others wandering through interstellar space. Its strange, elongated shape, unlike anything seen before, could have been the product of such a violent breakup. Over millions of years, the fragment could have been smoothed and sculpted by cosmic forces, like micrometeoroid impacts, radiation, and erosion by cosmic rays, giving it the bizarre form we glimpsed for only a few weeks. Other scientists proposed something even stranger, that Oumuamua might be a new kind of object altogether, not a comet or asteroid, but a category yet unnamed. Some suggested it could be made of exotic ices we don't commonly see in our solar system, such as molecular hydrogen ice. In this scenario, Oumuamua's acceleration could be explained by hydrogen sublimating invisibly into space, without producing the dust or water vapor tails we associate with comets. But this hypothesis raised further challenges. Could a block of hydrogen ice really survive the harsh journey across interstellar space without evaporating long before it ever reached us? Others suggested nitrogen ice perhaps chipped off the surface of a distant Pluto, like world orbiting another star. Still others thought about possibilities like carbon dioxide or carbon monoxide, all of which might sublimate in unusual ways. Each idea brought excitement but also new puzzles, for every explanation seemed to answer one question while creating another. Then came the boldest interpretation of all, that Oumuamua might not be natural. Harvard astrophysicist Avi Loeb made headlines when he argued that the most logical explanation could be that Oumuamua was some kind of technology, perhaps a probe or a fragment of a spacecraft sent by another civilization. He pointed to its strange acceleration, its thin and unusual shape, and its complete lack of outgassing as signs that it might be propelled by sunlight itself, like a solar sail. If it were an artificial object, perhaps a relic from a distant civilization, then humanity had just witnessed its first true evidence of extraterrestrial intelligence. Loeb's idea captured the public imagination but also sparked heated criticism from many of his peers. Most astronomers argued that extraordinary claims require extraordinary evidence, and in the case of Oumuamua, there simply wasn't enough data to leap to such conclusions. To them, the artificial hypothesis was exciting but premature. The debate became more than just scientific, it became philosophical. What does it mean when we encounter something we cannot explain? Should science remain cautious, clinging to natural explanations until all evidence is exhausted? Or should we be bold enough to entertain the possibility that the universe may be hiding truths far beyond what we expect? The conversation around Oumuamua became a test of human imagination. Some scientists warned against filling gaps in knowledge with speculation about aliens, while others reminded us that every great discovery in history began with someone daring to imagine what others dismissed. As the weeks passed and Oumuamua faded into the distance, our telescopes lost sight of it. The debates, however, only intensified. Without new data, the mystery could not be solved. That vacuum of certainty allowed theories to flourish. To some, it was simply a comet behaving in ways we did not fully understand. To others, it was a clue that our understanding of interstellar objects was only beginning, and to a few, it was a tantalizing whisper that we are not alone. What is undeniable is that Oumuamua changed the way we think about the universe. Before its arrival, interstellar objects were theoretical. After it, they were real. Its presence suggested that fragments and wanderers from other star systems may be common, passing through ours more often than we had imagined, simply too faint to notice until recently. This realization has fueled efforts to search for the next one, to be ready with faster telescopes, better detection systems, and perhaps even spacecraft capable of chasing one down for a closer look. Already, another interstellar object, 2I/Borisov, has been observed, this one clearly a comet, with a visible tail, reinforcing the idea that our solar system is regularly visited by messengers from beyond. The story of Oumuamua is still being written. It is a story of science wrestling with the unknown, of theories colliding and evolving in the absence of definitive proof. It is a reminder that the universe does not owe us easy answers, and that sometimes mystery is itself the gift, a force that drives us to look harder, think deeper, and dream bigger. Whether Oumuamua was a natural shard of rock or ice, or something crafted by intelligence beyond our own, it has already fulfilled its role as a messenger. It has carried a message not from its makers but from the cosmos itself, that there is more out there than we know, and that the search for understanding is never finished. In the end, perhaps it does not matter which theory is right. What matters is that Oumuamua reminded us that we are still students of the stars, humble before their endless lessons. It challenged us to keep questioning, to keep debating, and above all, to keep looking up, ready for the next messenger that will one day arrive. When Oumuamua was first detected in October 2017, astronomers knew immediately that the clock was ticking. This interstellar visitor was not lingering for us to study at our leisure. It was rushing past on a one-time trajectory, already moving too quickly to be captured by the sun's gravity. That realization meant that even as humanity marveled at this first confirmed interstellar object, we were also confronted with a painful truth. Our opportunity to study it was brief, and once it slipped beyond the reach of our telescopes, it would be gone forever. That departure and the scientific limitations it imposed is one of the most defining parts of Oumuamua's story. Oumuamua approached from the direction of the constellation Lyra, already traveling at a blistering speed of about 87 kilometers per second relative to Earth. By the time Pan-STARRS 1 spotted it, the object had already passed its closest approach to the Sun. This meant we were looking at it on the way out, not on the way in. Normally, when comets are discovered, astronomers have the luxury of watching them brighten as they move closer to the Sun, studying their composition through the gases and dust they shed. With Oumuamua, the opposite was true. It was already fading, dimming against the background stars as it fled the solar system. That simple fact set the stage for everything that followed. We had only a few weeks of usable observations before it became too faint for even our most powerful instruments. Those few weeks were filled with frantic effort. Every major observatory that could swing its instruments toward Oumuamua did so. Astronomers scrambled to measure its light curve, the way its brightness varied as it tumbled to estimate its shape and rotation. They tracked its trajectory with exquisite precision, trying to understand what forces were acting on it. They searched for gas, dust, and spectral signatures that might reveal its composition. Yet despite these efforts, limitations weighed heavily. The data we gathered was like a handful of puzzle pieces from an enormous jigsaw, enough to suggest outlines, but nowhere near enough to complete the picture. As Oumuamua dimmed beyond detectability, the frustration deepened. Astronomers are used to mysteries, but they are also used to having time. The planets are always there, orbiting predictably. Even distant comets give us months of warning. Oumuamua gave us only a fleeting glimpse before vanishing. This fleetingness imposed hard limits. We could not send a spacecraft to chase it down. By the time of its discovery, it was already receding too fast. Proposals were made, imaginative mission concepts sketched out on paper, but they all came too late. Practical spaceflight technology simply wasn't ready to mount an intercept mission on such short notice. So we were left with data from Earth, and only for a very short time. That limitation created a peculiar kind of tension in the scientific community. On the one hand, the data was fascinating, revealing an object with strange properties, an elongated shape, a tumbling motion, no visible coma, yet a measurable acceleration. On the other hand, the data was sparse. Each interpretation, whether natural or exotic, was based on inference from very limited evidence. This scarcity is what has fueled the enduring debates about Oumuamua's nature. The object's departure froze our knowledge in place. We cannot go back and gather more observations. The window has closed permanently. It is worth reflecting on just how final that closure is. Oumuamua is now hurtling away from us, deeper into interstellar space with every passing second. It is far too faint for our telescopes to see. Unless some unimaginable advance in propulsion allows us to chase it down far into the future, we will never get another chance to study it directly. It is, in every practical sense, gone. That sense of loss echoes in the scientific papers that have followed. Each study acknowledges, in its own way, that we are left with hypotheses we cannot fully test, interpretations we cannot decisively confirm or refute. In astronomy, data is everything, and in this case, the departure of Oumuamua meant the data stream ran dry almost as soon as it began. The limitations extend beyond science into philosophy. Humanity has always longed for messengers from beyond, signs that connect us to the wider galaxy. And here, for the first time, we truly had one, yet we could not grasp it. We could not hold it, sample it, or examine it up close. Oumuamua remained tantalizingly out of reach, like a voice heard through static, a message half received. That sense of missed opportunity has weighed heavily on astronomers, but it has also inspired them. Because if Oumuamua taught us anything, it is that we need to be ready next time, and there will be a next time. Statistically, interstellar objects like Oumuamua are likely not rare. The discovery of a second one, 2I/Borisov, in 2019 confirmed this. Unlike Oumuamua, Borisov looked much more like a traditional comet, complete with a coma and tail, and we were able to study it more thoroughly. Yet Oumuamua's uniqueness ensures it holds a special place. Its departure highlighted the need for new systems to detect interstellar visitors earlier, before they slip past. Efforts are now underway to make this possible. The Vera C. Rubin Observatory in Chile, with its wide-field survey capabilities, will be able to scan the skies more deeply and more frequently, greatly increasing our chances of spotting such objects as they approach rather than after they pass. If we can catch the next one inbound, we may have months or even years to study it and perhaps even send spacecraft to intercept it. That possibility reveals how Oumuamua's limitations can be transformed into lessons. Yes, its departure robbed us of certainty, but it also forced us to reimagine how we prepare for cosmic surprises. It challenged engineers to design missions that could be launched quickly, with the speed to catch an interstellar traveler. It encouraged astronomers to refine their surveys and detection algorithms. It reminded humanity that the universe does not wait for us. If we wish to learn its secrets, we must be vigilant and ready. The story of Oumuamua's departure also speaks to something deeper in the human condition. There is a melancholy in knowing we encountered a messenger from another star, only to watch it vanish into the dark. But there is also inspiration in that fleetingness. The fact that we even detected it at all is extraordinary. Just a few decades ago, our technology would have missed it entirely. The limitations we face now are, in some sense, a measure of our progress. We are reaching the point where the galaxy is beginning to reveal itself to us, even if our grasp is not yet firm. In a way, Oumuamua's departure is itself part of its message. It reminds us that the universe is vast and that opportunities come and go quickly. It teaches us that knowledge must sometimes be pieced together from fragments, and that certainty is a rare gift. It shows us the value of humility in science. We do not have all the answers, and sometimes we must live with questions. But it also shows us the value of perseverance, the determination to prepare for the next encounter, to ensure that next time we do not simply watch as the messenger slips away. As we think about Oumuamua today, years after it has vanished from sight, we carry both the frustration of limitation and the fire of possibility. Its departure closed one chapter but opened another. It left us with mysteries that still animate scientific debate, with theories that stretch from the mundane to the extraordinary. It also galvanized us to imagine missions that can fly faster, detect sooner, and study deeper. Its absence is, paradoxically, a presence of force shaping the future of astronomy and space exploration. Perhaps the greatest irony of Oumuamua's departure is that it made the object more legendary than if it had stayed. Had we captured every detail, pinned down every fact, it would be a fascinating day to point but little more. Instead, its mysteries endure, and in enduring, they inspire. We speak of Oumuamua not only as a rock or a shard of ice, but as a messenger, a scout, a symbol of the unknown. That symbolism comes precisely from the limitations we faced. Its departure ensured that it will always be more question than answer, more mystery than knowledge, and in that way, it may have served humanity even more profoundly than if we had fully understood it. In the silence of space, Oumuamua recedes, alone and unreachable, but here on Earth its story continues. It is told in classrooms and conferences, in debates and dreams. It is written into the plans of new observatories and spacecraft yet to launch. Its departure was not the end, but the beginning of something larger, a shift in how we see ourselves in the cosmos, and how ready we must be for what comes next. For even as we mourn what we could not know, we prepare for the day another messenger appears, and this time we will not simply watch it vanish. This time we will follow. When Oumuamua passed through our solar system in 2017, it didn't just leave behind a trail of unanswered scientific questions. It left behind something far more enduring, a legacy of curiosity, inspiration, and a reminder of humanity's restless longing to understand the unknown. Although the object itself vanished into the darkness, its brief visit changed the way we think about the universe and about ourselves. In many ways, Oumuamua's greatest impact is not what it revealed, but what it awakened: the realization that we are part of a larger, dynamic cosmos, and that if we wish to know more, we must look outward with both imagination and determination. The legacy begins with the sheer fact of its discovery. Before Oumuamua, the idea of interstellar objects wandering through our solar system was theoretical. Scientists suspected that countless fragments ejected from distant star systems must drift through the galaxy, but none had ever been seen. Oumuamua was the proof. In a single stroke, it transformed speculation into reality. Its detection told us that the solar system is not isolated but connected to the wider galaxy by a constant flow of interstellar debris. That realization alone has reshaped astronomy, giving rise to new fields of study and energizing the search for future visitors. It is one thing to believe something exists in theory, it is another to see it with our own eyes, but Oumuamua's legacy goes deeper than its role as a scientific milestone. Its mysteries forced us to confront the limits of our knowledge and the expansiveness of our imagination. Here was an object that did not fit neatly into existing categories. It lacked a visible tail, yet accelerated as though outgassing. It seemed elongated, perhaps cigar-shaped, perhaps pancake-flat, but unlike anything we had catalogued before. It spun, tumbled, and reflected sunlight in ways that confused our models. In short, it refused to be ordinary. That refusal became a spark for human curiosity. Scientists debated, writers speculated. The public, for once, found itself gripped by the details of astrophysics. For a few brief months, Oumuamua made the universe feel alive with mystery. This is part of its lasting gift. It reminded humanity that science is not only about answers but about questions. Too often, we think of science as a body of facts, a set of settled truths. Oumuamua showed us the opposite. It reminded us that science is a journey into the unknown, that mystery is the engine of discovery, and that the most exciting moments are those when we encounter something we do not yet understand. Its legacy is not certainty but wonder, the sense that the cosmos still holds secrets waiting to be uncovered. For astronomers, this legacy has already had practical consequences. The urgency of studying Oumuamua before it faded inspired the recognition that we must be better prepared for the next encounter. That is why new observatories like the Vera C. Rubin Observatory in Chile are being built with the explicit goal of scanning the skies more frequently and more deeply, catching such visitors earlier. That is why mission concepts are being explored that could launch spacecraft quickly, capable of intercepting an interstellar traveler within years rather than decades. The lesson of Oumuamua's fleeting visit is that time is precious and readiness is essential. Its legacy is literally shaping the future of astronomical technology and space exploration, yet the legacy extends beyond science into philosophy and culture. Oumuamua stirred questions that humanity has asked for millennia. Are we alone? Do other civilizations exist among the stars? Could this object have been a probe, a relic, or a beacon? While most scientists caution against leaping to extraordinary conclusions without extraordinary evidence, the mere fact that such questions were revived shows how deeply Oumuamua touched something in us. It reawakened the ancient human instinct to look up at the sky and wonder who or what else might be out there. It gave permission, even if briefly, to dream of possibilities beyond ourselves. This legacy of curiosity is powerful because it is not confined to laboratories or telescopes. It reaches into classrooms, inspiring young minds to pursue careers in astronomy, physics, and space exploration. It reaches into the arts, fueling novels, films, and stories that imagine what Oumuamua might have been. It reaches into everyday conversations, reminding people that the universe is not a distant abstraction, but an active, dynamic place, full of surprises that can pass through our own cosmic neighborhood. In this sense, Oumuamua's greatest achievement may not be what it was, but what it did to us. It reconnected us to the sense of wonder that lies at the heart of being human. Another aspect of its legacy is humility. Oumuamua showed us that despite centuries of studying the skies, we are still at the beginning of understanding the cosmos. We pride ourselves on our knowledge, yet here was an object that defied easy explanation, an object we could not chase, sample, or definitively classify. It reminded us that the universe is bigger than our categories, stranger than our expectations, and quicker than our instruments, that humility is not discouraging, it is motivating. It pushes us to expand our tools, to refine our models, and to accept that the unknown is not a failure but an invitation. The enduring debates around Oumuamua are themselves part of its legacy. Was it a comet with invisible outgassing? A shard of nitrogen ice? a fragment of an exoplanet, or something more extraordinary, perhaps even technological. These debates have not been resolved, and perhaps they never will be, but they keep the conversation alive. They keep scientists writing, thinking, and searching. They keep the public engaged, fascinated by the possibilities. The very fact that Oumuamua resists final answers ensures that it will remain a subject of curiosity for decades to come. Unlike other astronomical discoveries that fade into textbooks, neatly classified and understood, Oumuamua endures as a living mystery, and yet, perhaps the most profound part of its legacy is the reminder of connection. Oumuamua was not born in our solar system. It came from another star, another place we cannot even identify with certainty. It traveled for millions, perhaps billions, of years across interstellar space before arriving here. In that journey, it carried with it a piece of another world, not just metaphorically, but literally. Whether rock, ice, or something more exotic, it was material from beyond our sun's family, matter from another chapter of the galaxy's story. When it passed through our neighborhood, we were, for the first time in history, directly touched by a wanderer from another system. That sense of cosmic connection, of being part of something larger, is one of the greatest gifts Oumuamua has given us. Its legacy also challenges us to imagine the future. If Oumuamua was the first scout, the first messenger, then what might come next? Will we one day intercept an interstellar object and study it up close, holding in our hands the chemistry of another star system? Will we discover fragments that tell us about alien worlds, about planetary systems destroyed or reshaped? Or will we someday find evidence that something truly artificial has crossed our path, a probe, a signal, a crafted artifact? These questions now feel less like fantasy and more like possibilities. Oumuamua has shifted the boundary between science fiction and science fact, bringing the unimaginable closer to the realm of the achievable. There is a symbolic power in its Hawaiian name, Oumuamua, meaning scout or messenger from afar arriving first. That symbolism is itself part of the legacy. It suggests that Oumuamua was not just an object, but a herald, a sign that others will follow. It casts the encounter as the beginning of a story, not the end, and in doing so it leaves humanity with a sense of anticipation, of readiness, of waiting for the next messenger. That sense is not abstract. It is shaping the missions we design, the observatories we build, the questions we ask. It is also shaping the imagination of a generation that may be the one to witness the next encounter. Even in its absence, Oumuamua continues to influence us. Its departure did not end its story, it began a new chapter. Scientific papers continue to analyze the limited data. Mission concepts continue to be proposed, inspired by the idea of chasing down future Oumuamuas. Philosophers and thinkers continue to reflect on what its mysteries mean for our place in the cosmos. And ordinary people continue to look up at the night sky, knowing that among the countless stars, there are countless more messengers traveling unseen, waiting to cross our path. Oumuamua has become not just an object, but a symbol, a reminder that the universe is alive with motion, with connection, with stories beyond our own. In the grand arc of human history, Oumuamua's visit was brief. It came and went in weeks, leaving behind little more than a trail of data points and a storm of questions, and yet that is often how legacies are born. Sometimes it is not the long presence, but the brief encounter that changes everything. Oumuamua's legacy is the enduring curiosity it left in its wake, the fire it lit in our imaginations, the drive it gave us to be ready for the future. It is a legacy that will echo not only in scientific journals, but in the way humanity thinks about its place in the cosmos. One day, perhaps, another interstellar messenger will arrive, and we will be ready. One day, perhaps, we will capture a fragment, intercept a traveler, or even encounter something that confirms our boldest dreams. When that day comes, we will look back at Oumuamua as the first, the scout, the one that taught us to prepare. Until then, its greatest legacy remains alive within us, the insatiable, unquenchable human curiosity that drives us to seek, to question, and to imagine. For though Oumuamua has gone, the wonder it inspired has not, and in the end, that wonder may be the most important messenger of all.